So what does Newton's first law say? I'm going to write it out the long ways, but it's the right way to do that. And it says this: things at rest will stay at rest forever. That one makes sense. If I put a water bottle down and nobody moves it, it's going to stay there forever. But this is the one that's not common sense because people don't think about it this way. Things moving at constant velocity, and this is the crazy one, will continue moving at constant velocity for how long? Forever. That means that there is no net force required to keep you in a state of constant velocity. For some of you, this will be a really hard one because you don't really experience this. Whenever we see this, we call this what? Force-free motion. The object does not, it doesn't matter because there's no force required to be in this state. Then there's the line drawn in the sand. And it says this: if you are not at rest / constant velocity, then you are being forced to accelerate. And remember, what does this mean? Not means what? Speeding up, slowing down, or turning. That means that if you're speeding up, if you are slowing, or if you are turning, something is forcing you to accelerate. And that's really Newton's second law here. And so what this says here is that this thing sometimes is called accelerated motion. I like the word forced motion. You are being forced to be in that state of motion. So I kind of mentioned this already. Actually, I think I want to box this thing because this is a key thing for this chapter. Okay, that's Newton's first law. So I want to make sure that I say this because I want to be really clear. In many textbooks and websites, Newton's first law is called the law of inertia. And what they mean by the law of inertia is they define this quantity, mass. And what I'm saying is that this guy, in modern interpretation, is not correct. And I'll talk about it more when we get into the next chapter. When I define mass, it's Newton's second law that defines mass, not Newton's first law. Newton's first law essentially tells us the separation of that line, whether you're in force-free motion or whether you're in force motion. It's you're either at rest or constant velocity. That's what we mean by inertial. Or you're speeding up, slowing down, or turning. That's what we mean by forced motion. It really defines the coordinate systems where Newton's laws are valid. Okay, let's go. I keep talking about this thing called the net force. What do I mean by the word or phrase net force? Net force is what objects feel. So net force is the sum of all forces acting on an object reduced to one single effective force. And this one single effective force is what they call the net force here. So the net force is the sum of all of the forces that act on an object reduced to a single effective force. But here's the thing. Objects do not feel individual forces. Ever. And that's the crazy thing. Objects do not feel individual forces, but feel the net force. And what I mean by that is that if I have an object, let's say that this is my object right here. And so when I look at my object, and let's say that this is a top view. So what you would see here is that you would see something like this here. You would see here is that there might be a force pulling in that direction. There may be a force pulling in this direction. And there may be another force pulling in that direction. So what you're seeing here is that there's multiple forces acting on that object. This block does not feel force 1, 2, and 3. What it does here is it only feels one force. And in this case, I don't know what that one force would look like, but maybe this would be the net force. And it's a combination of 1 plus 2 plus 3. It only feels this. So if there was 3 people pulling with each of these 3 ropes, the net force that that object feels is just that one thing and nothing else.